you could fit over 1 million Earths inside our sun. But out there in the universe exists something far more extreme, a star so massive it makes our sun look tiny. Its name is Betelgeuse, a red supergiant nearing the end of its life. Betelgeuse is enormous. Scientists estimate it is between 14 and 20 times more massive than the Sun and up to 1,000 times larger in diameter. To put that into perspective, you could fit over 1 billion suns inside it. It's also unstable, constantly pulsing, with massive convection cells and violent surface activity. This star is essentially living on borrowed time, expected to explode as a supernova sometime within the next 100,000 years, maybe in thousands of years, or maybe tomorrow. Right now, Betelgeuse is located about 600 light-years away from Earth. At that distance, even when it explodes, we are safe. The explosion would be one of the brightest events ever seen in human history. For weeks, maybe even months, it would shine as bright as the full moon and be visible during the day. But beyond that incredible light show, it wouldn't harm us. The radiation and energy would spread out over such a vast distance that Earth's atmosphere and magnetic field would protect us. But things start to change if we move Betelgeuse closer. At around 160 light-years away, a supernova becomes more than just a spectacle. The explosion would send powerful X-rays and gamma radiation toward Earth. While it wouldn't completely destroy life, it could damage the ozone layer, the thin shield that protects us from harmful ultraviolet radiation. With that layer weakened, more UV rays would reach the surface, increasing mutation rates, damaging ecosystems, and raising cancer risks for living organisms. You might see intense auroras lighting up the entire planet, beautiful but signaling a dangerous shift. Move Betelgeuse even closer, to about 50 light-years away, and the situation becomes catastrophic. At this distance, the supernova could strip away much of Earth's ozone layer entirely. Without that protection, the sun's radiation would bombard the surface. The most immediate victims wouldn't be humans, but microscopic life in the oceans, like phytoplankton. These tiny organisms form the base of Earth's food chain and produce a large portion of the oxygen we breathe. Once they die off, the entire ecosystem begins to collapse, triggering a mass extinction event. Life on Earth would struggle to survive, and humanity likely wouldn't make it through. But the most extreme scenario is placing Betelgeuse right where our sun is. If Betelgeuse replaced the sun at the center of our solar system, the consequences would be immediate and absolute. Because of its enormous size, it wouldn't just shine down on Earth, it would engulf it. The radius of Betelgeuse would extend beyond the orbit of Earth, swallowing Mercury, Venus, and our planet entirely. There would be no sky, no horizon, just the inside of a star. For a brief fraction of a second, everything would be bathed in a blinding red-orange light. Then, instantly, Earth and everything on it would be vaporized. There would be no time to react, no chance to escape. The destruction wouldn't stop there. Mars would also be consumed. Jupiter would be exposed to extreme heat, potentially turning into a hot Jupiter, while Saturn's icy rings would melt and dissipate. The structure of the entire solar system would be transformed. The habitable zone, the region where conditions might support life, would be pushed far beyond Pluto, into the distant, cold edges of the system. And then, after all of that, Betelgeuse would finally explode. Its supernova would release an unimaginable amount of energy, more than our sun will produce over its entire 10 billion-year lifetime. All in just a few seconds. Any remaining planets would be obliterated, and the solar system would be replaced by a massive cloud of gas and dust, a nebula. From that debris, new stars and planets might one day form, continuing the cosmic cycle of destruction and creation. The good news is that none of this is happening anytime soon. Betelgeuse is far away, and it will remain there. But imagining scenarios like this reminds us just how powerful, and fragile, our place in the universe really is. And it leaves one question hanging. If a single star can do all of this, what would happen if something even more extreme replaced our sun?